This is problem 114 of Neetcode 150, coin change 2. So we're going to be given an array of integer representing coins with a certain value. And we're also going to be given a target amount. We can use each coins as many times as possible, but we have to combine them in a way that they reach the target amount. So if we take a look at this first example, we have a target of 4, and we have the coins 1, 2, and 3. So from what we can see, we can combine 4 times the coin 1. That's going to give us this amount. We can also use 2 times the coin 2. We can use 2 times the coin 1 plus 1 time the coin 2. And we can use 1 time the coin 3 plus 1 time the coin 1. Right, so just to solve this problem, we're going to use dynamic programming by using a bottom-up approach. So let's go on a whiteboard and see how we do this. So let's set our amount is 4 again, and that our coins are 1 to 3, like this. So what I will do is that I will create a grid with all the coins in the vertical line and all the possible values up to the amount that we can have. That's going to be the horizontal line. So I will also create an additional row here at the bottom. You'll see why afterwards. And the first thing that you notice is that in the vertical side, you basically have like a line of ones, and the reason is that you, for each coin, if you don't take it, you're gonna have a sum of 0. So if I have a bill of $100 or I have a wallet of $10 million, in both cases, if I don't take it, I'm gonna have $0. So this is why you have basically one you have one way to get $0 for whatever the value is on that vertical line. So this is why we have ones. And now what we're going to do, we're just going to try to see how many times we can make each amount here with these coins. So how many times can we actually make 4 given these the coin 3? Well, 0, right? Because right now we're not going to take a look at the possibility of adding 1 to 3 to reach 4. We're just going to say, like, if we only have 3, like a bag of coins containing a bag of coins with the value of 3 only, we are not going to be able to reach 4 in any manner, but we're going to be able to reach 3, right, just by picking 1 coin. 2 is not something we can do yet with a bag full of 3s, and 1 is not something we can do. All right, so now if we go 1 row up and we see the 2, we're going to try to see if we can complete 4. So can we do 4 basically with 2s? Well, the answer is yes, right? So there is a way to have 4. So we can put a 1 here. Can we do a 2? Well, now we have to consider that when we are at this 2, we have to think of our bag now as having 2 and 3 coins. So this is why every time we are at a particular case, we're just going to go 1 row down to see what the value is. And if it is 1, we're just going to set it equal to 1, because we know that if we have a bag containing 2 and 3s, and we set the case under it as a 1, meaning that there's one way to actually get that amount, well, we know that in this bag we're going to be able to reach this amount even though we don't pick that particular 2. We know we're going to be able to reach 3, so we're going to put a 1. And also we basically wanted to see if we are able to basically to complete the value 3 with another value. So let's take a look at the other possibilities. So can we actually use, let's say, a 2, for example? So can we use a 2 to complete a 3? Well, if we take the difference between the amount 3 and this coin 2, we have 1. So we're going to have to take a look at, can we actually can we take a look at, can we actually have basically a 1 with these coins? So with a bag containing 2 and 3, is there a possibility of us having an amount of 1? It is 0, right? So the answer here is going to be no, and we're still going to have a 1 at this position. All right, so I think that we can also complete this case here. So we know we have a 1. And now if we go one row up, well, following our algorithm, we're just going to go see one case down if we can achieve the value 1 um, with a bag containing 1, 2, and 3 coins. Well, no. But can we do this with basically a bag containing also ones in it? Well, how we're going to do that is that we're just going to take the difference between 1 and 1, so the amount and the coin itself, and this is going to give us a 0. And this is also why it is helpful to have like this this column of zeros, is because we know that when we're at 3 and we want to see if we can reach the amount 3 with our coin 3s, what we're going to do is that we're just going to take the difference. You're going to see 3, basically the amount, minus the coin itself. And this still gives us 0. But this is why when we have exactly the same amount, well, when a coin's value is exactly the amount that we're looking for, we know we're going to fall back to our 0 row, and this is going to give us a 1. So here at the case, well, at the row of the 1 and at this the column of the 1, we're going to go at our default column of 0, and we're going to see that we can actually make up this amount with ones in our bag. And now we're going to go to the right. So let me just erase this because it starts to be a little bit messy. All right, so now that we are here at the 2, what we're going to do is that we're going to go take a look down, see if we can actually make 2 with the other coins in our bags. We see that if we have a bag that contains 1, 2, and 3, we can actually already make the combination 2, or we can actually reach the amount 2 with the other coins in our bag. So we know that we're for sure going to have a 1. And we also want to see if basically the amount, so 2 minus 1, which is 1, right? Is there a way that we can reach this difference? Well, we're just going to have to take a look at the case 1, see if there's a possibilities. And now there is one possibilities. So we're going to add 1 to this. So we're going to have a 2. And same thing here at 3. We're just going to go one cell down, see if we can make up this amount 3 with the other coins in our bag. Well, yes, because we have a 1. And if we take that amount minus the 1, we want to see if basically we can, with that coin 1 only, ever reach that difference, which is 2. And can we do that? Well, yes, because if we take a look at 2 here, there's actually 2 ways to do that. So there's 2 ways to do basically this difference. So we're going to have to add this 2 plus basically the single way to reach 3 with the other coins in the bag. And this is going to give us how many ways we have to reach 3 with all the coins in our bag. And now same thing for the 4. We're going to go see 1 cells down, and we see that with the other coins, there's one way to actually reach that. So it's going to be at least 1 as far as we know. And then we're going to take that difference, and we want to see if that difference can be made up with the other coins in the bag. So with a 4 and a coin of 1, we know that we now have a new target of 3. And can that target be made up actually? Well, we can just move to the left and see that yes, it can be made up. So it's actually more than one solution. There are 3 to make up 3. So we're going to add 3 to this one. And now we can see that we are actually reaching on these top right cells at the answer. So the answer we are looking for is actually 4, right? This is what we use to, this is the initial solution. So you can have basically, you can have 4 times the coin 1. You can have 2 times the coin 1 plus a 2. And lastly, you can have a 3 plus a 1. So and there was there was another solution. So um, you can also have 2 times 2, right? So these are the four solutions. Uh, so we are going to get that numbers, and this is what we have to return. We have to return that number 4. So let's go ahead and code this now that we understand the logic. So first thing, I will just create a variable n that is going to contain the len of coins. So I don't have to say len coins every time I need to refer to this. I also want to sort the coin because this is going to be easier for us um, to then deal with our logic, because we always want to start with the biggest number, see if we can reach up to some directly. But yeah, that's something we want to do. We just want to start it right away. Then you want to create our grid, and we initially want a grid to be zeros, and we want to have the number of of possible sums that are gonna go up to the amount. So we're gonna say basically times amount plus 1, right? So if the amount is 4, well, we want to know, like, if can we do 0, can we do 1, can we do 3, can we do 4? So this is why we're gonna have basically amount plus 1 of zeros, and we want to have this basically times the well, we want to have basically this row for every single number inside the array coin. So I will just say for camel case in the range of n plus 1. So up to there, it makes sense. Now we actually have to make sure that the row of the sum 0 is going to be is going to be a 1, right? Like in our example. So to do so, we're going to have a for loop. So I will say for I in the range of n plus 1. So we're going to go for every single row, and I want to reach the first index. So this first index is going to be it's going to be a 1. All right. So with that being said, we can actually start the algorithm. So notice that we were starting from the last row, but inside each row we were like starting from the first index up to the last index. So I will go for basically I in the range of n minus 1 up to the index 0, and in a reverse order. All right, so this is how we are going to start from the last row and go up to the top row. And now I basically want to say for a in the range of amount plus 1. So we go from left to right inside each rows. And the first thing I want to check is basically if that particular amount is at least equal to, maybe can be greater than the coins at this index. So basically, it just means that in our example, for example, if the amount is 2, so if 2, like 2 is already smaller than 3, so we know there's absolutely no way to make up the amount 2 in a bag full of 3. So this is what we're doing now. We're just saving us some time. So we're just gonna do this in the case where the amount is actually greater or equal than the coins. So you could potentially skip that part, but it will just make the algorithm a little bit slower. So what you want to do is that we initially want to set that value to the case that is one cell lower than the one that we're at. So we're going to take basically the cells at the current row and at the current amount. And initially, this is going to be equal to basically the value that is just one cell lower than this. So it's going to be just the row under it. So like that. And then what are we doing? We're just taking that difference and seeing if there's inside that same row there is a way to actually achieve that that difference value with the coins that we have in our bag at that moment. So we were doing basically dp at that index I and at that's sum a, and we were incrementing to it basically the dp inside that same row, right? We're never changing the row, we're using the same one, but you were always using that difference, and that difference is basically the amount that we were looking for minus the value of the coins at that index. So this is like when I was speaking on the whiteboard, I was always like pragmatically following these steps. So uh, that's really it. And at the end, what were we returning? Well, we're returning basically the first row, and at the column of the amount. So let's test this out. This will work. We're gonna be able to, yeah, it's worked. So we can speak about the time and space complexity. So we're using basically a bottom-up approach in a 2D grid of a dynamic programming solution. So, and we went through every single cases. So if we say that the number of coins is basically n and that the given amount is a, well, we're going to go through a grid that is n times a length. So we're going to have a time complexity of n times a length. And we are also creating basically a DP, so dynamic programming 2D grids that is of the length n times a. So we're also going to have a space complexity of big O of n times a. With that being said, I hope you enjoyed the video, and I hope to see you in the next one.